Have you ever wondered how computers work? It's like magic, isn't it? You click a button and things happen on the screen, but behind the scenes, there's a whole world of tiny parts working together to make it all possible. Today, we're going on an adventure to explore three of the most important components inside your computer: the CPU, RAM, and storage. Don't worry, we'll use simple language and fun examples so you can follow along. These three components are like the key players in a team. Each one has a special role to play, and they need to work together seamlessly to make your computer run smoothly. Let's meet the team. The CPU, or Central Processing Unit, is like the brain of your computer. It's the most critical component, responsible for interpreting and executing most of the commands from the computer's other hardware and software. It's the control center that tells all the other parts what to do. Just like a control center in a busy airport, the CPU coordinates all the activities, ensuring that everything runs smoothly and efficiently. Think of it as the conductor of an orchestra, making sure everyone plays their part at the right time. The CPU ensures that the computer's memory, storage, and other components work in harmony, just like musicians in an orchestra. The CPU's main job is to process information. It takes raw data and turns it into meaningful information that your computer can use to perform tasks. This involves complex calculations and logical operations. It takes instructions from programs and executes them, performing calculations and making decisions at lightning speed. Whether it's running a simple application or a complex simulation, the CPU handles it all with incredible speed and precision. It's constantly working, even when you're just browsing the internet or typing a document. Every click, every keystroke, and every action you take is processed by the CPU, ensuring that your commands are executed instantly. Imagine the CPU as a chef in a busy restaurant kitchen. The chef must manage multiple tasks simultaneously, from preparing ingredients to cooking dishes, just like the CPU handles multiple processes at once. The chef, CPU, reads the recipes, instructions from programs, gathers the ingredients, data, and prepares the dishes, executes tasks. Each step must be done correctly and in the right order to ensure the final dish is perfect. Just like a chef needs to be quick and efficient, the CPU works tirelessly to keep your computer running smoothly. It never takes a break, constantly processing data and executing instructions to ensure your computer operates seamlessly. Over the years, CPUs have evolved significantly. From the early days of simple processors to today's advanced multi-core CPUs, the technology has advanced rapidly. Modern CPUs are capable of handling billions of instructions per second, making them incredibly powerful and efficient. Today's CPUs are designed to handle multitasking with ease. Whether you're running multiple applications, streaming videos, or playing games, the CPU ensures that everything runs smoothly without any lag or slowdown. In data centers, powerful CPUs are used to manage vast amounts of data and run complex algorithms. These CPUs are the backbone of the internet, powering everything from search engines to social media platforms. For creative professionals, a powerful CPU is essential. Whether you're editing videos, designing graphics, or composing music, the CPU ensures that your creative applications run smoothly and efficiently. Gamers also rely on powerful CPUs to deliver a smooth and immersive gaming experience. The CPU processes game logic, physics, and AI, ensuring that games run at high frame rates and with minimal latency. When building or upgrading a computer, choosing the right CPU is crucial. A good CPU can significantly enhance your computer's performance, making it faster and more responsive. In summary, the CPU is the hard-working brain of your computer. It processes information, executes instructions, and ensures that all the components work together seamlessly. Whether you're browsing the internet, working on a project, or playing a game, the CPU is always at work, making sure your computer runs smoothly and efficiently. RAM, or random access memory, is like your computer's short-term memory. It's a temporary storage space where the CPU can quickly access the information it needs to do its job. Think of RAM as your desk while you're working. You keep the most important things you're currently working on within easy reach on your desk, right? That's what RAM does for the CPU. RAM is super fast, which is why your computer can switch between different tasks quickly. However, unlike storage, RAM is volatile, meaning that the information it holds is lost when you turn off your computer. It's like clearing your desk at the end of the day. Storage is where your computer keeps all its data safe and sound. This includes your operating system, programs, documents, photos, music, and everything else you've saved on your computer. Unlike RAM, storage is permanent. The data remains there even when you turn off your computer. Think of it as a giant library where all your information is stored on shelves. There are different types of storage, such as hard disk drives, HDDs, and solid-state drives, SSDs. SSDs are much faster than HDDs, which is why they're becoming increasingly popular. Section 5, Teamwork Makes the Dream Work: How CPU, RAM, and Storage Interact. Now that we've met our three key players, let's see how they work together as a team to make your computer run smoothly. Each component has a unique role, and their seamless interaction is what ensures your computer performs efficiently. When you open a program, the CPU fetches the program's instructions from storage and loads them into RAM. This process is crucial because the CPU needs quick access to these instructions to execute them efficiently. The CPU then starts executing the instructions, accessing the data it needs from RAM. RAM acts as a high-speed workspace, allowing the CPU to retrieve and process data much faster than if it had to access the slower storage every time. If the CPU needs to save any data, it sends it back to RAM or storage. This ensures that the data is preserved for future use, whether it's for ongoing tasks or long-term storage. Think of it like this. The CPU is the chef, RAM is the countertop where the chef prepares the ingredients for the meal, and storage is the pantry, where all the ingredients are stored until they are needed. The chef, which is the CPU, takes the ingredients, which are the data from the pantry or storage, and places them on the countertop, or RAM, for easy access while cooking. This allows the chef to work efficiently without having to constantly go back to the pantry, and places them on the countertop, or RAM, for easy access while cooking. This analogy helps us understand how the CPU, RAM, and storage work together to ensure that your computer runs smoothly and efficiently. The CPU relies on RAM for quick access to data, while storage provides a more permanent place to keep data when it's not in use. When running multiple programs, the CPU constantly switches between different sets of instructions and data stored in RAM. This multitasking capability is what allows you to have several applications open at once without significant slowdowns. Sometimes, when RAM is full, the system uses a portion of the storage as virtual memory. This process, known as paging, helps manage the workload, but can slow down performance since storage is slower than RAM. Upgrading your RAM can significantly improve your computer's performance, especially if you run memory-intensive applications like video editing software or games. More RAM means more space for the CPU to work with, reducing the need to use slower storage as virtual memory. Similarly, upgrading to a faster storage solution, like an SSD, can also enhance performance. SSDs provide quicker data access compared to traditional hard drives, reducing the time it takes for the CPU to fetch and save data. In summary, the harmonious interaction between the CPU, RAM, and storage is what keeps your computer running efficiently. Each component plays a vital role, and understanding their interplay can help you make informed decisions when upgrading or troubleshooting your system. Section 6, Real-World Examples, Seeing the Big Three in Action. Let's look at some real-world examples to see how the CPU, RAM, and storage work together in action. These three components are the backbone of any computer system, and their seamless interaction is what makes modern computing possible. When you open several tabs in a web browser, each tab's data is loaded into RAM. This allows for quick access to the information on each tab without having to reload the page every time you switch between them. The CPU can then quickly switch between the tabs, making it seem like you're browsing multiple pages at the same time. This multitasking capability is crucial for productivity, allowing you to research, write, and communicate all at once. When you edit a photo, the photo's data is loaded into RAM. This allows for real-time adjustments and edits without any noticeable delay. The CPU then processes your edits, applying filters, adjustments, and effects. Once you're satisfied with your changes, the final image is saved back to storage, ensuring that your work is preserved for future use. Video games require a lot of processing power and fast data access. The game's data, including textures, models, and sounds, is loaded into RAM to ensure quick access. The CPU works tirelessly to render the game's graphics, process user inputs, and manage the game's logic. This collaboration between the CPU and RAM ensures that the game runs smoothly, providing an immersive and responsive gaming experience. In video editing, the CPU, RAM, and storage work together to handle large video files. The raw footage is loaded into RAM, allowing for smooth playback and editing. The CPU processes your edits, applying transitions, effects, and color corrections. Once the editing is complete, the final video is rendered and saved to storage, ready for sharing or further refinement. For software developers, the CPU, RAM, and storage are essential for compiling code and running applications. The source code is loaded into RAM, and the CPU compiles it into executable programs. This process requires significant computational power, and the efficiency of the CPU and RAM can greatly impact development speed. Once compiled, the programs are saved to storage, ready for testing and deployment. In data analysis, large data sets are loaded into RAM for quick access and manipulation. The CPU processes the data, performing calculations and generating visualizations. The results are then saved to storage, allowing for further analysis and reporting. This seamless interaction between the CPU, RAM, and storage is what makes complex data analysis possible. In music production, the CPU, RAM, and storage work together to handle multiple audio tracks and effects. The audio data is loaded into RAM, allowing for real-time playback and editing. The CPU processes the audio, applying effects and mixing tracks. Once the production is complete, the final mix is saved to storage, ready for distribution or further refinement. In 3D modeling, the CPU, RAM, and storage are essential for rendering complex models and scenes. The model data is loaded into RAM, allowing for smooth manipulation and rendering. The CPU processes the rendering, applying textures, lighting, and effects. Once the rendering is complete, the final model or scene is saved to storage, ready for use in animations, games, or simulations. In virtual reality, the CPU, RAM, and storage work together to create immersive experiences. The VR data is loaded into RAM, allowing for real-time interaction and rendering. The CPU processes the VR environment, rendering graphics and managing user inputs. This collaboration ensures a smooth and immersive VR experience, making you feel like you're truly inside the virtual world. In AI and machine learning, the CPU, RAM, and storage are crucial for training models and processing data. The training data is loaded into RAM, allowing for quick access and manipulation. The CPU processes the data, training the model and making predictions. Once the training is complete, the model is saved to storage, ready for deployment and use in real-world applications. In cloud computing, the CPU, RAM, and storage work together to provide scalable and efficient computing resources. The data is loaded into RAM, allowing for quick access and processing. The CPU processes the data, managing resources and ensuring efficient operation. This collaboration ensures that cloud services are reliable and responsive, providing the computing power needed for modern applications. Section 7. Visualizing the flow, animations, diagrams, and more. Sometimes it's easier to understand how things work when you can see them in action. Imagine an animation showing data flowing between the CPU, RAM, and storage like a network of roads with tiny cars carrying bits of information. Or picture a diagram of the system bus, which is like a highway connecting the CPU, RAM, and other components. These visual aids can help us grasp the complex interactions happening inside our computers. Section 8. Mumbai connections, bringing it home with local analogies. Let's bring it home to Mumbai with some local analogies. Imagine the CPU as a traffic controller managing the flow of vehicles, data, through the city computer system. Just like a traffic controller needs to keep things moving smoothly, the CPU ensures that data flows efficiently between components. Or think of RAM as a bustling marketplace like Crawford Market, where vendors, CPU, quickly access goods data to serve customers' tasks. RAM's speed and accessibility are crucial for efficient data processing. Section 9. Keep exploring. The adventure continues. Congratulations, you've just completed a crash course on the CPU, RAM, and storage. But our exploration of the amazing world inside your computer doesn't have to end here. There's so much more to discover. Keep asking questions, reading, and exploring. The more you learn, the more you'll appreciate the incredible technology that powers our digital lives.